Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about Zettabyte file system or ZFS. So let's dive right into it. So what we are talking about? We are talking about a file system. Now you have to understand, a computer can only work as long as it can store a file and retrieve it. So it cannot just like, oh, I'm storing file. Most of us have experienced that we bought something, we stored in our house, we forgot where it is, we literally bought another one because we could not find it. So that cannot happen in a computer. Computer has to know which file it's stored and where. So not only it has to deal with storing file, it also has to deal with retrieving it. So it also needs to path to the file also has to be stored. And every data, when you're talking about just data, also has a what we call a metadata layer. Now this metadata, think of it this way, it's data about the data. For example, I'm taking a photo. Okay, photo is the data. What would be the metadata? Metadata would be when it was shot, when where it was shot, what was the aperture setting, what was the ISO, what was the camera model, what was the taker's watermark and all that jazz. That would be metadata layer. So, and sometimes metadata could literally be an independent file. So sometimes it will be like file except data tag is inside that quote unquote container. Sometimes it could be literally like, okay, this is the file and this is the metadata file of that. So metadata is always there in all file formats, and everything basically, and it has to be handled carefully. If you mess that part up, the end. Because metadata also helps in one thing, that is permission, handling permission and privileges. For example, Windows has a very good permission structure where it knows for a fact that there are certain OS level files that thou shall not tamper with directly. Like you may be like, oh, that's hand holding on that. Like that's the primary reason why people have such a hell of a issue with Linux. It's like Linux is awesome, no denying that, but it's like it requires you to know everything from day one, because you can literally destroy Linux with one minor command. Because again, it does allow you to go that deep. And Windows is like, yeah, I know, like most people think that they are like, ZWiz and like hacker and all that. They are not, and all they're gonna do is brick their system. So no. So it's one of those things. Permission and privileges, it has to be handled, and it has to be handled very carefully. Mess that part up, the end. And then you also have to deal with data corruption and fault. And this is one thing that you have to understand. Computers are not reliable. Flat out, they are not reliable. You go to a processor level, it's not reliable. You go to RAM level, it's not reliable. Heck, it's so unreliable that we had to build an ecosystem to make it reliable. We call it ECC. And you go to hard drive, it's not reliable. There is nothing in a computer that is reliable at all. Like, you need proof of that. Research how many layers of error correction is there and to what level it goes there. Like, it would be shocking. Like, whoa, kind of shocking, where it's like, dude, the amount of error correction that we have in the system. Like hard drive, it does its own error correction. You have operating system, it does its own error correction. CPU, it does its own error correction. File transfer protocol, it does its own error correction. It's like, holy damn, the amount of error correction we have to do. So basically, one person said it wisely. I have linked the video down below, where it's like, computer, like from outside it looks reliable. It's like, you're working, it rarely falls apart, like, and it's strong, robust and all that. But here's the inside is just magic and pixie dust. Like, nobody knows how does it work. And that's why, like, we always have a blue screen. It does not make sense. It's like, what exactly did it broke? It's like, what did not broke? So data corruption, faults, these are common thing, and OS has to be written in such a way it can handle it. File system specifically, it's like, oh, something went missing, I have to handle it. I cannot just crash because somebody renamed an important file. So faults, corruption, it has to handle that, and should be efficient with IO operation. Can an engineer write something that is so strong, so robust that it's like, I got this? Absolutely. Problem would be the processor did not get this. Meaning you could literally have a scenario where your computer, it's like, okay, I'm a computer, I'm working, and my ideal usage is like 80% of my processor. It's like, why? Yeah, I'm just making sure files are never, ever, ever corrupted. So it's another aspect of that also. So it has to be efficient, meaning given the minimal resource basically requirement, it has to do maximum amount of work while making sure all the data layer is taken care of. So you have hard drives have partitions have file systems have directories have files that you and I interact with. So think of it this way, like you are doing DaVinci Resolve, or you are doing Photoshop, it's requesting file. Who is requesting the file to? So it's asking, like, let's say Windows, it's like, bro, need some file. Windows is like, who the hell Windows goes to? Windows goes to file system. NTFS is like, bro, can you fetch me this file? That goes to the storage medium, be it hard drive, be it SSD, whatever have you. That goes to the actual location and finds the file and transfers the file. So that whole pipeline has to happen as efficiently as possible. That's why you never slow down your computer because you're copying goddamn file. So what's the problem? Well, problem is there are many systems that we use in day-to-day life and they have limitations. For example, there is a very good chance if you are not too young, you must have heard about this FAT system, file allocation table system, and you must have dealt with this frustrating issue with pen drives, cards, or red mag, where it's like single file cannot be more than 4 terabyte. I have no idea why the heck red is still stuck in this, but it is, and that's why like if you use a red camera, you take out the red Mac, put it in computer, open the video file, it's like 4 gigabyte, 4 gigabyte, 4 gigabyte because it's fat file size limitation. And if you had let's say 5 terabyte file, hard drive basically, and you went there and you want to partition it, it will only show you 2 terabyte. You have to create 2 partition in order to cover all of it. So these are just a dumb example. Now, why do we use FAT? Again, it's so old, so well integrated in everything that almost everything has the way to read it. So there is an upgraded version of that, that is exFAT, extended FAT, and that does bypass this issue also. But you get that point. Like there is always limitations, especially with old system. Like FAT is ancient. Even NTFS does have some limitations. And then we created the system back in the days, like back in the 1980s. We created a system of hardware RAID. Basically, put a computer on a chip, PCI bus, and this bus will do data computation, meaning it's going to create what we call data parity. You take the data, split it into part, stores the basically parity calculation. So if one hard drive goes boom, you still can restore your data. Now, it did work, but there was a problem. The problem was like, how do you know which hard drive went? Like you may be like, if one hard drive literally went offline, that's awesome. But what if you had corruption? Then created a problem where it's like there was no actual way of knowing which hard drive was corrupted, unless the hard drive itself was like going a dead fault, where it's like, no, I no longer what RAIDs are like, I got this. The moment they have minor fault, silent carriers, those sort of things, it cannot do anything. So enterprise grade created a solution for this. It's like when you go into hard drive, it has blocks. So generally hard drives have around roughly 512 bits of blocks. Now, that's good, that's awesome, it does work, but it does not have enough space. So somebody created the idea, it's like instead of having 512-bit block, let's have 520-bit block. Now, like why the heck add extra 8-bit? That 8-bit would be used to store checksum of that 512-bit. Because if you do not do that in one block, you have an issue where it's like you have to have one empty block. So one full block, one empty block just to store checksum. So it's like, no, let's make the block itself bigger and store like instead of 512-bit of data and 8-bit of checksum. So now we can read the block, then read the checksum and be damn sure which one is correct, which one is corrupted. Now it does work for enterprise. And if you ever wondered why the heck enterprise SAS drive, hard drives are so idiotically expensive per terabyte wise, that's the reason for that. Again, is it like a magical technology? Hell no, it's just a configuration. They just realize every company, like be it Western Digital, be it SM, SanDisk and all that, they realize it's like, hey, we can charge a lot for enterprise. So they did. So RAID literally cannot do anything. And again, in silent killer kind of scenario where you have bit rot, RAID has no idea that bit rot even happened. Like it's inherently not designed to check the data. You just hope that operating system check it. And the biggest issue with RAID systems is like it relies on the hard drive to tell the RAID controller is like, bro, I'm out. If that does not happen, let's say you have a faulty system, error system, it will literally corrupt your correct data. That's why nowadays every Tom, Dick and Harry who is building NAS, who is building servers will flat out tell you, thou shall not use RAID. Thou shall always use host bus adapter. RAID flat out is useless against bit rot, meaning you can save a file and from RAID's point of view, everything is fine and you bring back your file back, it's this. It has happened enough time that nobody touches RAID in enterprise anymore. That's why you will see so much RAID card in eBay anymore nowadays. Nobody touches it anymore. Everybody's like either go about JBOD or just go with software RAID. So RAID flat out not a good hardware, and not to mention it also requires batteries. So if your batteries runs out and there was some write file operation, that write file was in the RAM and you lost power in the battery, the end. It can even corrupt the system. So many file systems like that we use in day-to-day life does not have integrity verification, meaning NTFS is a very good example of that. It does have some fail checks, but it cannot be damn sure. It's like, I saved this file. It cannot just be like, let me check it. Oh, no, file is corrupted. It cannot tell you like that. It's like, here's the file. You stored it here. Here's the file. I'm opening it. It's just doing like this. It's like, bro, you stored that file. It's like, no, you corrupted it. So many file systems do not have any proper way of integrity checking, let alone rebuilding, meaning once you found it, ideally you will have 2 hard drives and you will like using the parity calculations, you'll like, bro, this part is the corrupted part. Let's me repair the corrupted part with the correct part. And now you have backup again. So that's the problem. That's the problem that ZFS is trying to solve. So let's come to ZFS. Now, ZFS was made by Sun Corporation in 2001, this puppy basically, and they were awesome company according to people, and the R&D work they did was god tier. Basically, they were like Ferraris, and they did amazing work. I have linked the video down below where I'm ripping this data off, and they did everything well except monetization. They were awesome, they just did not know how to monetize. So they reached a point where they knew very well that their company is going to go bankrupt, so they made it open source. The technology that developed for ZFS, they made it open source, and it could have like millions to billions of money poured into development and research. Again, file systems are not a child's play. It does require some serious horsepower to build. So they spent that serious horsepower. So rather than just wasting all that labor, they're like, okay, let's just make it open source. At least somebody can use it, and everybody loved it. Then Oracle came in. Oracle bought Sun Microsystems in 2009. Now, Oracle wanted ZFS back. And this is roughly the time where Apple actually wanted to use ZFS in their Mac OS. And Oracle was like, no, bro. And again, Oracle does have deep enough pocket and big enough clout that they're like, if they go to Apple, it's like, bro, Apple will be like, okay, bro. So that created a scenario where Oracle left bad taste in people's mouth, even though the data was open source. So OpenZFS was created. OZFS. Now, this puppy was created for freedom. Basically, again, for legal requirements, you had to create a scenario where there was like no contact between these two. So OpenZFS was created. So now Oracle cannot touch this puppy. It's like no. There's like flat out no. And Oracle, if they try to go there, now FTCP, basically US government will fire missiles at Oracle, and their missiles are bigger than Oracle's missiles. So Oracle will go boom. So for that reason, OpenZFS is now free to use, like truly free to use. You do not have to worry about it. And again, you can run Windows on OpenZFS if you want to. Now, that's the complicated basically licensing and all that jazz. What about the core principle? Like, what is different about ZFS compared to everything else? Well, ZFS was built with, again, server people. So they had a very simple philosophy. And this is the time when Google came to be. And the philosophy was trust nothing, meaning flat out don't trust anything. What was the norm at that time is like, if you were Yahoo, you're going to buy server, you're going to have server grade hardware, you're going to have server rooms, you're going to have awesome, and then that's how you're going to run your software. Now, what Google does is like, is there a junkyard sale of old computer? Okay, awesome. Bring that puppy in, build your server, and if server goes boom and actually catches on fire, which it did happen, it was like, okay, software, eject that puppy, keep running. And that created a light bulb moment for people of Sun Microsystems. They realized that future is not hardware, future is software. And again, they have come true, because again, we no longer use RAID cards, we use host bus adapter, and everything has switched to software. And they looked at that core principle where it's like cheap hardware, no modification at all, and that's it. You just make sure software does everything. And that's the whole point. That's the core philosophy of ZFS. So yes, there were systems which will allow you to have a hard drive and parity check every data, but that required that 520-bit system, which is not common. So that requires extra money. They're like, what if we F that system? Like, bye. I'm not going to pay that much, but I do everything that I need to do on software level, or I recreate the structure where I can do everything that you were doing only on software level, so I can actually use inexpensive disks. So that's the whole point. So core selling point of OpenZFS is robust data checking, meaning this puppy is not something where you have to worry about checksums. This is like, I got this. So meaning you give, in 2009, you give basically OpenZFS, this is the file, it can return you in 2900, and the file will be the damn file. It will not have even a single bit rot into it. That's the whole point. It's so damn robust. It's like, I got this. It has like trust nothing philosophy. So trust has, we have a saying, right? Trust but verify. That's ZFS. And because again, server people were building it and they were kind of far thinking out, they built a 128-bit architecture. Basically, this whole architecture is big. What does that mean? This means like some people have big, this is like huge. What does that mean? That simply means this puppy can go to 16 exabytes. That's humongous. To give you a context, NTFS modern one can only go to 8 petabytes. Like this puppy is so far out, it's like, bro, it's not even funny. It's like, bro, you need to have few zeros added to it before you reach this point. Like there is no point where right now you can build anything that can come close to this. Like flat out, nothing, like nope. It's no. On top of that, the reason why it's so robust and reliable in terms of data, it has copy on write, which many people call cow. Now, this is Windows. Now, imagine in this way, you have a Windows system and you have a file. Awesome. Now you're like, I want to rename the file. Awesome. You rename it. What happens on the file level? Like, what happened to that data block? It gets rewritten. Exact that data block which stored the file gets rewritten. Now, you may be like, okay, that does not sound that bad, but here's the deal. You are talking about electrical things, meaning it's not instantaneous. There are like, it takes time to write a file. What happens in that time? Let's say some corruption happens, power loss, something big, bad, boom, and voila, now that data block is corrupted because again, you were writing to it. And that time something happens, it's the most vulnerable state. So, boom, your hard drive goes poof. Now, it does have some benefits, meaning you can literally, like some kids used to do that if like they stored a lot of porn in their computer, and if their mom and dad is tech savvy enough when they wanted to check it, so they store a lot of porn, delete the porn. So parents look at, oh, okay, file is clean and all that, computer is clean and also. When the parents went away, they do data recovery, all the porn. Very tech savvy kids. And then we have this puppy. Now this puppy, if you can look at that, like compared to this block diagram, you have this basically copy on diagram. What it does is like, if user sends you a command, it's like, bro, rewrite this block, or basically it's saying rewrite this file, you know the file is in there. It will be like, okay, I'm not touching that file. It's like, nope, it does not even touch that. It creates a new block of data, writes in that. Once that write is complete, that it knows that file has been thoroughly like copied from RAM to CPU to the RAM block. It's like confirms everything. Only then it unlinks the last file. Like the previous version, a previous file tree, it tampers with it. It's like it only tampers it once it knows it's like completely, the next one is completely done, then it removes the old one. And it still keeps that in a backup image, so to say. So if while you are writing a new block, something bad happens, let's say power failure, no problem. Operating system literally looks at it, it's like, I think you did not do anything. File will never be corrupted. There won't be any tampering with it. So that's the whole point. Copy on write only. It only does basically stamps it. Basically, I have made a change. Once it's damn sure that it has actually completed everything, and the way it's designed in such a way where it's like it does not touch the data block that has already in use. So it cannot corrupt it. Like if something is there, something is working, it will not touch it. It's like, no, I will not mess it up by writing operation and all that. So that's the ZFS way. And it's like the file tree, like how if you delete your files in a system, you're not actually deleting it. You're not going there and erasing the blocks. All you are doing is just deleting the file tree data points. Basically, where the files are stored, your operating system forgets or file system forgets. So you can retrieve it. Again, that's also a desirable function for servers, because if you have a lot of transitions going on from your servers, like money transitions and all that jazz, you do want a scenario where it's like something bad happens, your server goes down, you want to go back to a known state. So go back to the known states, the file tree is there. And ZFS is very robust against that. Like it has checksum built into it. Like you do not have to worry about checksum. It takes care of the checksum on its own, and everything is designed in such a way that it can scale to ludicrous level. Meaning you have JBots, which are like freaking building size JBot, just a bunch of disk. It will like, bro, I got this. I can monitor all of that, all of it. Hundreds of petabytes is like, bro, I got this. Don't worry about it. So that's ZFS. Then we come to what's the use of this sort of thing. Well, it's basically a file system which has many use cases, from server of home level, basically if you are building it in your home, to enterprise grade. And yes, even though it's like open and all that, does not mean it has no use. Heck, even Oracle was like new enough where they are investing a lot of research and development. They like figured out how to do encryption and all that. Again, that's a paid branch that you have to buy an Oracle system to get that. But again, it's a very important, very successful, very reliable, and you can literally go to companies and maybe even Facebook or Amazon and Netflix and all that. You will like, wait a minute, your server literally, I'm not even joking, literally could be storing the data in ZFS file system. So it is something that is serious. It's not something that's like, oh, free software is like VLC. No. This is backbone. This is like how Linux is important to the server industry. Same way. It's like strong, robust system. Now, high reliability data storage. That's the whole MO of it. And data scrubbing for maintenance. If you recently watched any video about Linux tech tips going boom in their server, this part was the messed up part. And this again, this is the logic of Windows. Windows knows for a fact that some function should not be exposed to the user. User should not be allowed to make that mistake. Somehow in the basically operating system that Linux was, basically Linux tech tips were using, it had data scrubbing as an option, but that option had a switch to turn it off. It should not be there. It should not be there. Like, no, bro. No, no, you shall not turn it off. So the idea of data scrubbing is that bit rot happens, but it happens over time. It's like you have the data, you check it now, everything will be fine. But again, do you know everything would be fine after 1 month? Or again, if you waited too long, you could have so much bit rot that you may not be able to rebuild the array. So the idea of data scrubbing for maintenance is that you have a time, you figure it out like how long it's going to do the data scrubbing, and computer can give you an estimate. It may be like giant server could take around a week. So it's like every month you spend scrubbing. What does scrubbing mean? You literally read every block. Every block you read, check it against the checksum, reinforce everything. If there is a fault, you fix it using basically the parity calculations you already have, you fix it. And if something is throwing too much error, you just alert the user where it's like, bro, one hard drive is going, but the data is intact, please replace the drive. So data is scrubbing for maintenance, and that's the reason why basically server grade file storage system can give you so much reliability. You try that with NTFS, lol. So again, I can't blame NTFS. Again, I wish Microsoft has switched to this, but I think even they were like pissed off by Oracle. They're like, who cares? It should have happened. Like, we should have had this sort of system where it's like awesome thing where you have hundreds of hard drive connected into VDEV going into Z pool, so you no longer even have to worry. It's like how many hard drives you can put. You just put as much as you want, 500, 600, 7,000, who cares? So you can go YOLO on it. And it can also do what we call hardware sharing for dissimilar use. For example, you can literally have one hard drive base that are like very large capacity but slow. You can have another one like NVMe, and it can be a completely different. So you can literally have multiple things dealing with different use cases. Some like just basic big ass file size transfer, awesome. Some could be like a database query request. It's like lot of IOPS. I got it. Same hardware. Like physically it could be the same box, and that box could literally be handling multiple different use cases where like few big sequential file, lot of small random IOPS. It can take care of that. Like you have data integrity, advanced security, enterprise grade, block level replication, unlimited snapshot. That's another aspect of that cow protocol, where it's like because it's recreating a new block every time you do any modification. All it stores is the delta between change A and change B. So that delta information is very small, very, very, very small. So it can store surprisingly large amount of it in the same hard drive. And going back, quote unquote, rolling back is like, done, go home, sweet dreams. That's how easy it is. Data reduction and disk volume manager, you can go YOLO on it. Like OpenZFS, you can go YOLO on it. You can do bonkers things with it. Not even joking, like you can go YOLO on it. But we come to the final aspect of it. It's not a backup. It's not meant for backup. It's just a good as file system, which I hoped Windows have used, but well, we live in Microsoft world now. So if you have one copy of data, like for example, I'm genuinely serious about my photography collection. And again, it's not like a masterpiece or something, but it's like family photos and important for me. And I would be really sad if I lost all of them. So if I had only one copy of it, I don't have any copy. I have nothing, just zero, nothing. I'm just running on hope at that point in time. So remember this, if you have one copy of data, that data is already gone. If you are lucky, you may be able to retrieve it, but generally it's gone. So before that happens, please make sure you have two. So if you have two copies of data, then okay, you have one copy. But if you really want data redundancy, meaning no matter what happens, I have this damn data till the end of my life, well, you have to go with what's called 3, 2, 1. Now, 3 means 3 copies of the data. Data has to be in 3 physically different places, not just like, oh, one hard drive, I have 3 copies of it. No, 3 physically distinct places. It has to be in 2 mediums, meaning let's say one is a hard drive, another could be LTO tapes, or like in my case, Blu-ray drives. It has to be like, 2 mediums also should be there, and one has to be offsite, meaning this is my house, I have like, let's say 2 servers taking care of it. But if I'm, burning Blu-rays and with all my photos, I have to make sure that I send the Blu-ray disc to somewhere else, like to my brother who is living in different state. So if anything bad happens, I still have the ability to recover those puppies. That's the whole point. So how does a corporation deal with it? Corporation generally has one main server. Now I used to work in basically 3D game artist, as a 3D game artist in a studio, and we had a main server. Now that server, depending on how many people you have, like we had like 100 people working in there. So every night the data would be backed up. But if you had a server that was like worked on like a lot of people, like 600, 700, the backups could be hourly. Again, you have to understand, like 700 or 800 people working per hour, they're doing a lot of crunching work. So you do not want to lose even 1 hour. So again, backup duration is the lost time. In our case, we could lose 1 day of work. Again, small company, it can tolerate that. But if you are talking about large company like TCS, Tata Consultancy Services, which could have like 500,000 employee, yeah, backup could be 15 minutes, because again, even 15 minutes of loss of whole system, yeah, no. So you have main server, Then you have backup server that is cloning everything. And then you have offsite LTO tapes. That's how enterprise does that. I'm doing it Blu-ray because again, photos don't take that much space. Other than Blu-ray, there is nothing else that I can actually count on for long term. I can try DVDs also, but again, 8 gigabyte, not too much. So that's how server industry, basically people who are dealing with this, that's how they are taking care of it. And that's the only way you can be damn sure you do not caught with your pants down, basically how Canon was. There's like, basically we got ransomware. It's like, okay, go to your offline backup. Oh, you did not had offline backup. That's why you have to have offline backup. Basically, if a virus infiltrates your system, you should be like, okay, offline backup, let's isolate everything. Offline backup, make another backup of it, then dump it. So that's the easiest way to figure out if you have a basically compromised system. If you have a system that is like completely gone, that's the easiest way to verify that. They did not have that. Like, this is goddamn Canon. And they're just like, lol, oops. So you have to understand, 3-1 is compulsory. Otherwise, oops, you are just one oops away from getting destroyed. And ZFS is a good tool. Basically, if you are building a server for yourself, it's a good tool. It's under no circumstances a bad tool. It's a good tool. It's awesome, but it's not gonna do anything against basically ransomware or a user error. That's why like it needs so many backup images. And you are responsible for your data. This you have to understand. Even though company like data backup and all that, most of the time they are not that reliable. And again, they are not responsible for it. It's like, it's a good to have function, but you are responsible for your data. So if I say I would like to have all my photos, I'm responsible for it. And trust me, you do not want to be in a position where you do something today that your future self will curse you for. You do not want to be that. Like, I do not want to be the Anupam Vipul that I was back in my past, where I was storing files, all my photos, and I did not rename them with a date and time. How stupid of me. If I had stored all of them in date and time in the name itself, so even if I recover the file, even if the file was corrupted or damaged or I try to repatch it, I would know which file was damaged, because again, date and time in the name is the best place to store it. Again, that's for my way of operating and all that. I could have done that, but I did not. But again, there is a Chinese power for it. Best time to plant a tree is 30 years ago. The next best time is now. I'm 30 years old. So I'm doing what I can do now. So be mindful. You are responsible for your data. You have to follow 3-2-1. You cannot be just like, I have data redundancy because I am using ZFS. That's good, but you are one bad day away from poof. So that's up to you. That is very critical, very important. So this was my presentation on ZFS. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and if you are free. And as always, thanks for watching.